Hello, scholars! It's your boy, Mr. Siegel, here to talk to you about trigonomic identities. Now, what a trigonomic identity is just like any other kind of identity. Now, if you think about, what is an identity? It's what makes something what it is. Like, what makes Daisy who she is? What makes Mozart who he is, besides being tall and having glasses? Well, you know some identities. You know the reciprocal identities already. We learned about this. Secant, you learned, is 1 over cosine. That's what he is, right? Cosecant is 1 over sine, and cotangent is 1 over tangent. These are all things that you know already. We've also learned these, that tangent is the same thing as sine over cosine, and cotangent, which is just the reciprocal, is cosine over sine. So these are all the things that we've learned so far. These are the identities we know. All right? Now, what we're going to learn is some new ones right here. Specifically, this is the big one. Cosine squared theta plus sine squared theta equals 1. What is what you're saying? Yeah, I know. It's true. I'm about to prove it to you. But just for now, I just want you to focus on this. This is a new identity. It's called the Pythagorean identities, and it's just cosine squared theta. If you square the cosine value and you add that to the square of the sine value, you get 1 every time. Don't believe me? Check out this proof. Come down over here. Yup, here it goes. Now, check it out. If you remember, let's say I draw a line in the unit circle. This is a unit circle. And if you remember, all the radiuses in the unit circle equal to what? Right, the radius is always equal to 1 in a unit circle. And we also remember this. The sine value is always equal to your y value, and your cosine value is always equal to your x value on the circumference of the circle. So let's say we're looking at this point right here, okay? And we're going to drop this down, make a right triangle. So right now we have a triangle, right? I just made a little triangle with its point right here on the circumference. Well, let's say I wanted to find the hypotenuse, right? I could just use the Pythagorean theorem, which is a squared plus b squared equals c squared, right? That will help me in a right triangle find any of the sides. Now what I know is this. I know that my radius, or my hypotenuse in this case, is equal to 1. So for c, I could just put 1 squared in there, right? I also know this. Whatever is right here, the length of this side right here is my x value, right? So instead of a, I could just put x squared, right? And whatever my height of this is going to be my y value. So I could just say y squared. Now follow me here for a second because it's about to get cray up in here. Instead of writing x and y, we know that cosine is equal to the x value, right? So I could say, instead of writing cosine, I could say the cosine, right? The cosine is always equal to x plus my y value is always equal to sine. So instead of writing sine, I could just say the sine. Why am I writing the thetas? Because remember, the sine of theta is equal to 1 squared. And if I were to simplify that, that's just, oh, whoops. And so what I know is simply this. Cosine squared theta, if I square the cosine value, plus sine squared theta is equal to 1. And that is the proof of this identity that we have right here. Boom. Alright, now these two we could ignore for now. We'll explain those more in class, but I just want to concentrate on this one. This is our main guy. Cosine squared theta plus sine squared theta equals 1. That's going to help us a bit today. So what we're going to learn today is like proving identities. They're kind of like puzzles, alright? Now, I'm trying to prove that tan theta plus cosecant theta equals secant theta. That these two things are equivalent to each other, and I have to prove it. Well, to do that, what I'm going to do is use all the identities that I know. Okay? Now, the way to do these is to write everything in terms of sine and cosine. So tangent, cosecant, and secant are things that I could write in the terms of sine and cosine, right? What I mean is using the reciprocal identities, and we could just put these in different terms. The other thing I know is that I only want to usually work on one side. So start on just working on one side. So what I know is this. Tangent is equal to sine over cosine. So a sine theta over cosine theta is the same thing as tangent. That's just one of the identities, right? Cosecant we know is 1 over sine theta. That's another one of the identities, okay? And we're just going to leave this like this, secant theta, okay? Now looking at this, you'll notice that we could do a little math here, right? Because I have a sine here and a sine here, we could just cancel these out. And what that leaves me with is 1 over cosine theta is equal to secant theta. Now is this true? Well, we know that 1 over cosine theta is equal to this because secant is just the same thing as 1 over cosine theta. And this is how we prove that two things are the same. We just use these identities that we know. Let's take another look at one, okay? We want to prove that tan theta times sine theta times cosine theta equals sine squared theta. Well, like I said, we want to write everything in terms of sine and cosine, all right? And we're going to work on this side of the equation. So tan can be written as sine over cosine, sine theta over cosine theta. Don't make fun of my handwriting. Times, well, sine theta stays sine theta, times cosine theta stays cosine theta, and this equals sine squared theta. Now, how can I prove this? Well, whenever we have fractions, we like to drop these ones under them, right, to keep everything constant. And since this is all multiplication, I can cancel out these cosines. So this cosine and this cosine cancel out. So that leaves me with, when I cancel this out, sine squared theta, sine theta times sine theta equals sine squared theta. Well, sine theta times sine theta is just like x times x, which gives me sine squared theta. And so I know that these two are equivalent. That would be considered a proof. Let's try two more of these, and then we could call it a day on this lesson. Here's where it gets a little tricky, okay? Now, like I said, we're going to work on only one side of this equation, and we're trying to prove that sine theta times cosecant theta minus sine theta is equal to cosine squared theta. The first step is always write everything in terms of sine and cosine, all right? That's going to help us prove it. So we're going to write sine theta, well, that's already in terms of sine, is equal to, well, cosecant is 1 over sine theta minus sine of theta equals cosine squared theta. Okay? Now we're just going to work on this side for now. So I'm just going to go like that. Now we got to distribute. So this times this and this times this. So what we get when we distribute is, well, sine theta times 1 over sine theta is sine theta over sine theta minus, well, sine theta times sine theta is sine theta squared. Okay, and as we know, this is equal to cosine squared theta. Now we got to add these. Ooh, well, let's see. This is over 1. And how are we going to add these? Well, we know that this is equal to 1. So I'm just going to say sine theta over sine theta is 1 minus sine squared theta equals cosine squared theta. And here's where we could get a little funky. What do we know 1 is equal to? What identity did we learn about that? Well, I know that 1 is actually equal to cosine squared theta plus sine squared theta. Right? 1 equals that. That's one of the identities we just learned. So, with that, I'm going to replace 1 with that, and I'm going to minus sine squared theta. I'm just bringing this down. So this the 1 was just equal to that, so I just replaced it. Minus sine squared theta equals cosine squared theta. And to subtract these now, this and this cancel out, so we just get cosine squared theta is equal to cosine squared theta. And that's how it's done. Alright guys, good luck.